Hi everyone, in this tutorial you are going to learn how to conduct correlation analysis using RapidMiner. This tutorial is loosely based on Dr. Matthew Norse's Data Mining for Masses book. I have already imported the data file that I'm going to use for the correlation analysis, and here I'm going to drag and drop it into the process window. And then connect it to the results port and run the file to get the summary statistics and to view the data. So when I run it, I'll get a data view. Let's go to statistics and get to know our data a little bit better. The data is coming from a company that is in the business of selling heating oil. Through this analysis, we want to possibly come up with suggestions that can help the company to increase its revenue. Now let's get to know our variables a little bit better. We have installation, which is basically a density rating. It ranges from 1 to 10 and indicates the thickness of each home's insulation. A home with a density rating of 1 is poorly insulated, while a home with a density rating of 10 has excellent insulations. Temperature. This is the average outdoor ambient temperature at each home for the most recent year. It measures in Fahrenheit degrees. Heating oil. This is the total number of units of heating oil purchased by the owner of each home in the most recent year. Number of occupants refers to the total number of occupants living in each home. Average age refers to the average age of those occupants, and home size is a rating on a scale of 1 to 8 of the home's overall size. The higher the number, the larger the home. And as you can see, we have no missing value and all the ranges correspond to what we expect from our data understanding. Now let's go ahead and see how we can conduct a correlation analysis using this dataset. Let's go back to design. The RapidMiner operator for correlation is called correlation matrix, which results in a correlation coefficients matrix. Let's go ahead and find it. So you can see correlation matrix is here. Let's drag and drop it, and I'm going to drop it right on top of the line. You can go to help and read about different inputs and output ports on the correlation matrix. So you can see it'll take an example set or data set. The output is example set, its matrix, and its weights. We have normalized weights for parameters, and you can go with a squared correlation, which will give you the R squared or squared correlation, which can give you some information on the shared variability between your two variables. Let's go back to the design, and now we have correlation matrix. Let's click on it, and you can see under the parameters normalized weights are checked, and you should leave it like that unless you have a strong reason to uncheck the normalized weights. Let's go ahead and run this model. As you can see, it did not generate anything. Do you know why? Think about it. The reason is that I did not connect the matrix output to the results. Basically, the example set output, it led through the example set without any processing. But I needed to get the matrix, the correlation matrix, out of this operator. Now I connect matrix port to my results port and run it again one more time. Okay, this time I get the correlation matrix. I can see that here installation with installation does have perfect correlation because it's 1 to 1, and then you can identify some other strong or semi-strong correlations. The good thing about RapidMiner output correlation matrix is that it's color coded. The denser the violet, the stronger the correlation. So you can see that, for example, temperature and insulation, they do have a strong negative correlation. And average age and temperature, again, strong negative correlation. Is there any other correlation that interests you? Look at average age and heating oil. It's a strong positive correlation. So what does it mean? It means that the higher the average age or the older the resident of a home, the more heating oil they are going to use. So what does the negative correlation between temperature and insulation tells you? It tells you the lower the temperature, the average outside ambient temperature, the higher the insulation for home. Basically, homes in colder areas of the country will have higher insulation. So look at these results and try to analyze these results. Now try to think what business suggestions, what business solutions you can drive out of the results of this analysis that help you make more money, that help your company to generate more revenue. We can discuss this in class when we meet next time. But it's your job to think about different ways that companies can leverage, or this company can leverage this information to make more money, to increase their revenue. You can also look at the pairwise table instead of the correlation matrix. It's basically essentially the same. You can see that attribute X, attribute Y, and the correlation. Now let's see if you can eyeball these correlations using scatter plots, using charts. The charts on this window refers to the charts generated based on the results. These are different charts and they're usually not very useful. In order to look at the charts that are generated based on your raw data, you need to go to your retrieve correlation data or your retrieve operator results. Let's go back to your data and we can go to charts. And let's look at the scatter matrix. Remember heating oil and average age? Let's go back to scatter and X heating oil, Y average age. As you can see, there is a nice pattern in data. There are some data points that do not follow the pattern, but you can see, you can identify the overall positive upward slope pattern that resulted in that strong high correlation between heating oil and average age. Okay, so at the end again, think about possible business suggestions, possible business implications of the results of this analysis, and let's discuss them in class.